Welcome to the Orion meeting. This is our first meeting in a couple of years in person, and it'll be interesting. But we've got a good crowd. It's a hybrid meeting in person and on Zoom, apparently. Seems to be working. So glad to have our speaker, Dr. Robert Compton, with us tonight to explain the difference in height. Let me tell you something about this man. He is from Metropolis, Illinois, the home of Superman. Seriously. And so I think that's my explanation for the difference in height. He did receive his BS, MS, and PhD in physics at ORION, University of Florida and University of Tennessee. He was a senior corporate fellow at ORION. That is a very big deal. He was that for about 10 years. He was at ORION and retired for 32 years and became a professor of physics and chemistry at UT for 22 years. And he's now an emeritus professor. So he's done some good things at the lab, especially in laser physics and at UT. He's a fellow of the APS, AAAS, and OSA. Spent sabbatical at University of Paris and the FOM Institute in Holland. He was a S-Crime fellow in New Zealand and gave 8 two-hour lectures on the topic of the Manhattan Project. So Bob and I talked about this maybe 3 years ago, and I've been wanting to hear this. So in that time, he has given already his 3rd Orion lecture, and they're always really, really good. So I got an opportunity today to ask him if he would tell us about the Manhattan Project. So Dr. Compton, welcome to a chaotic hybrid session. We have the blame when things don't work. You have the floor, the microphone, and our gratitude.
Okay. Yeah, and anybody who came here thinking that we're going to hear about the James Watt telescope, I'll close my eyes and you can leave. Okay, well, thank you very much, David. I'm always anxious to talk about the Manhattan Project. It's sort of a personal thing with me. And when Dave asked me late this afternoon if I would be willing to come down and speak to and I was anxious to do so. I thought I would talk about the Manhattan Project, but in view of what's going on in Europe and with regards to Putin and Russia and Ukraine, I thought it would be worthwhile to talk about the moral implications of the Manhattan Project and where we are, particularly the young people here in the department in school. Yeah, I gave this talk probably 2 years ago at the back then the Doomsday clock was down to 100 seconds due to global warming and nuclear threats. And Trump was saying, my nuclear button is much bigger than North Korea's. So I don't know where the Doomsday clock is now. I started to look for that this afternoon, but I didn't have time to do so. But I thought it would be worthwhile to talk about some of the implications of what happened with the Manhattan Project and where we are today. So as Dave said, I grew up in Southern Illinois. And this is my father right here and all of his brothers. And when the Japanese bombed Pearl Harbor, all of these guys except this guy, he was a little older. This is a picture before 1941, but all of these guys lined up and were all over the world. This guy, Ken, was in North Africa and Anzio Beach. This guy through 44 missions, bombing missions over Pulaski oil fields and over Germany. This guy was in the Signal Corps. This guy was a jet pilot trainer, and he was killed in the war. This guy spent his career in the Philippines, and he showed me the results of killing 21 Japanese hand-to-hand combat. He had a chest that he brought back from the war there, showing the something from every one of those that he shot. My father had joined the Navy and someone came to the house and said, Mr. Compton, you did really well on these exams. I remember this. I was probably 4 years old at that time. And we're going to send you to a place called Oak Ridge. And he said, no, you're not. I'm joining the Navy. And so they brought back somebody with a lot of stripes on their shoulder. And he said, you're going to Oak Ridge, Tennessee. He didn't know what it was about. And in fact, just as an anecdote here, we never talked about what he did during the war. We'll see more about that later. Let's start with the following. The fission was discovered in 1938. That was when I was born. And Hahn and Strassman, and Wise Meitner was the head of that group in physical chemistry there in the institute there. And she had escaped. She was Jewish, and so she had escaped before the war and went to the Bohr Institute with Niels Bohr. And she learned about this. They told her what had gone on. And she apparently, it's apocryphal, said that she was on a skiing trip with her cousin Otto Frisch. And they discovered that the fission products that they were talking about were lighter than the initial uranium that they had been put in their reactor. And when she realized that, she said, oh, E equal MC squared, and did a calculation and came up with a really high amount of energy that's released in that. So she relayed information to the US through these four people here. How many of you heard of these guys? Leonard Szilard, John von Neumann, and Edward Teller, and Eugene Wigner. Eugene Wigner was one time head of the Oak Ridge National Laboratory. These four guys, if I'd been in that high school class, I'd be a bricklayer today rather than a physics major, because these are four really eminent scientists, and they were in the U.S. at that time. They'd all moved over, and Szilard told Enrico Fermi about this, and they started work on the graphite reactor below the Stagg field, and they found that not only could they get fission of uranium to occur in a controlled chain reaction, they also were producing plutonium. And that's an important point that's sometimes missed in this whole story. This plutonium is more unstable in terms of making a bomb out of it. And also, you didn't need to separate the 235 and 238. We'll talk about that now in a second. So after this pile reactor was generated and shown what would happen, then Szilard put together a letter that he asked Albert Einstein to sign and take to President Roosevelt. And here's this letter, and I'll let you read it if you can see it there. But basically it says that Fermi and Szilard had been communicating with me in the manuscript to suspect that uranium may be turned into a new important source of energy, in particular a bomb. And so the net result of all of this is that the chances are that a good high energy bomb could be built using this uranium film. They think it would have been too heavy to put on an airplane. You'd maybe bring it in on a boat and let it go off. But nevertheless, that ignited the interest in this. And so Szilard Albert Einstein took this letter to Roosevelt and convinced him that they should start a project, mainly because they were afraid the Germans were building one, because the Germans had discovered this process. And so they were more concerned that the Germans would build it. And so Roosevelt asked Senator Kenneth McKellar from Tennessee, chairman of the Senate Appropriation Committee. He was summoned by Roosevelt's office where the president said, Mr. Chairman, we need to hide $2 billion in the appropriations bill to win World War II. McKellar responded by saying, well, Mr. President, I only have one question. Where in Tennessee will that $2 billion be spent? And so the rest is sort of history. That started the whole Manhattan Project in Oak Ridge and Chicago and Los Alamos and Hanford. We'll talk about the dollars and cents in a moment, but that was it. Some of the big three in the process here of making the bomb was Oppenheimer, whose characteristic carried a cigarette with him wherever he went. Back in those days, everybody smoked. But Fermi and Lawrence, E.O. Lawrence, and we'll talk about him as regard to the separations process. some of the elite scientists at that time were getting together. All these guys must have told a pretty good joke here, but they're all laughing. And one of them was E.O. Lawrence, and the other was A.H. Compton. I had about a 30 to 40-minute talk with him when I was a graduate student at Gainesville to see if we had any common ancestors. And fortunately for him, we didn't. Vanderbilt Bush, J.B. Conant, and here's Carl Compton, A.H. Compton's brother. And over here is a little-known scientist. His name is Al Loomis. He was a very wealthy physicist. He had made a lot of money with companies that he had owned, et cetera. And he started a radiation lab with his own money. And the radiation lab was making radar. And it's sometimes said that the bomb ended the war, but this radar won the war because it was, you could see on cloud, through clouds, et cetera, et cetera. So he should be noted more often than he is. So here's the problem. The uranium on Earth exists as 238 and 235 uranium, 92 protons and either 146 or 143 neutrons. And when the Earth was created, there were equal numbers of these, but as time went on, about 4.5 billion years, the Earth had been 4 billion years, the 235 is only 0.7%. It's more radioactive, more unstable. To make an A-bomb necessary, you had to enrich the 235 to 90%. Otherwise, the neutrons that are released in this would have been snuffed out by the 238. This required a physical separation. Physical separation is hard compared to chemical separation. The plutonium created in the graphite pile reactor needed only to be separated from the uranium to make a bomb. This was done chemically, which is much easier than the physical separation of the uranium isotopes. So you could do a chemistry to separate the plutonium. So I'm getting ahead of myself here, but there was 3 plutonium bombs and 1 uranium bomb built around 1945. So the Manhattan Project was mainly a separations plot. Everything you see here in Oak Ridge was here to separate physically and to some extent chemically the isotopes of uranium and plutonium. And the way it looks even today, except that the K25 is gone, here is the Y12 in the valley that you see here, and there's a mountain here, and then there's ORION, which is here, which I spent a long time. And this is the gaseous diffusion plant. I actually worked at all 3 of these plants, 1 summer at Y12, 3 summers in the gaseous diffusion plant, and then my career was in Oak Ridge ORION. Actually, they hired me here to play fast pitch softball, but I won't go into it. They found I wasn't too bad as a scientist. So here's what the Y12 area looks like in the Manhattan Project back then. A little bit different today. What is it? It's basically, you use uranium chloride, not uranium hexafluoride. You use, and I could go into this. I did a lot of work on uranium chloride and UF6. And they make the UCO4 and then ionize it, and the UCO4 ions would come around, U plus and U235 and 238 plus ions would make it through this magnetic field here and be collected. The 235 is lighter and it's caught here, and the 238 is caught there. What they found out when they first turned all this on is that, yeah, you could get nice separation if the beam current was low. But it turns out when you get the beam current up high enough to make a good separation, then these ion interactions blew the beam up so that you couldn't separate the 2 beams over here. And that was really a stumbling block. They were all really nervous when they first built this thing, because they didn't think that they would be able to solve it. It would have taken 20 years or so to separate enough uranium for a bomb had this. And the way they solved this is to put a gas inside the Ds of the mass spectrometer, which we'll see in a moment. And as the ions went through there, they would knock off electrons from the background gas, and those electrons would neutralize the positive ion current. Okay, this was classified for quite a long time, this knowledge. Here's some of the calutrons. See how big they are. Here's one source, here's another source. So there's actually 2 machines here collecting 235 over here. And you can see how big they are. And it's a man standing here. They had magnetic fields that went around like this. Can everybody see the magnetic field that goes around like this. That magnetic field was pretty high to bend the uranium, and each one of these slots here is two of these mass spectrometers. Okay, for separating the material. So you can see how many there are. I think there were 4 alpha tracks at the plant. And to generate the magnetic field, you can see here, this is silver. And the silver linings came from the Treasury. And the silver was paid back to the Treasury, I don't know, a number of years ago, maybe 20 years ago, well after the war. And so this was one of the stumbling blocks in the whole process. In fact, they had a fire, the ions, the breakdown between the coils were giving them a problem for a while. That was a stumbling block. Here's what the inside of one of these looked like. You had one source going this way, another source going that way, another going this way, another going that way. And so each one of these, there were 4 of these separators inside one of those slots. And then there were a lot of them around the outside. I hope that comes out to you. So that's what the thing looked like. My father worked on this during the war. This was what he did when he came here during the war. We lived on Reed Lane out in the west end of town. Here's what they look like when you're getting ready to put them in. Isn't that amazing? This is a huge thing. So this is one of the mass spectrometers that has 4 inside of it. And then there were these so-called calutron girls. Here you go. Calutron girls who sat there, and their job was to turn variac to maximize the 235 and minimize the 238. So they would maximize the current. You didn't have robo back then. You didn't have computers back then to do anything. So these girls, they found out that they were much better than men, particularly to stay there all day and do that. So my father was behind these people here doing the work on the inside. And interestingly enough, even though my field is physics, my dad and I never talked about what he did. I'd love to have done that, but he just was not talking about. Everybody he knew what he was doing. I mean, he knew he was making uranium-235. He was that far up on the ladder, but he was not a real scientist out there. So these mass spectrometers here would give about 20% separation, which is not enough for a bomb. So they take that 20% separated material, make uranium tetrachloride out of it again, and then they would put it in these mass spectrometers, which is called the beta calutron. And these would enrich it up to 90%. There was also another huge project, as big as or bigger than the Y12 project. This is the gaseous diffusion plant. And this is where you're pressurizing UF6 through a barrier of nickel type material. And as the UF6 goes through the barrier, the 235 will get through faster than the 238, and you can separate the uranium hexafluorides that way. And that was, this used more electricity than the whole state of Texas at the time. And the reason it was so expensive, you had pumps that had to pump this gas through that barrier, really high pressure pumping, and the temperature inside this building was roughly 130, 140 degrees. So people who were working on it could only stay in there a certain period of time. My uncle worked in this after the war, the one that was on Anzio Beach. He worked in this after the war, but they were still separating uranium at that time. And he said that they had to drink and eat salt tablets and then come outside for a while to get their body temperature down and go back in and work some more. I actually took some samples from here to the mass spec when I worked out there during the 3 summits that I was in. So one of my problems was to do the mass separation, mass spectrometry. Then the graphite reactor at ORION, which you may have seen because you could go and visit. I think it's getting ready to come back again. What you do there is you put uranium in this block of graphite here. You can see all the holes to put the uranium in, and it would breed to make plutonium, and then you would use this rod to push the material that's bred out the back. So some of it would be uranium, some of it would be plutonium, and then they would do the chemistry on that to separate the 235 from the 238. And some of that 235 would then go to Y12. And I'm sorry, no, I'm wrong about that. some of the plutonium would go to Hanford for to make the plutonium bomb. So the first bomb was made and tested in Los Alamos on July the 16th, 1945. So in 3 years, they had started from scratch and had a bomb. This was a plutonium bomb. They were much easier to make. We only made one uranium bomb. That's what I'm told. And Oppenheimer was standing and watching this, and he said, quoting from the Bhagavad Gita, "Now I become death, the destroyer of worlds." And he said, "I suppose we all felt that way one another." So this was a bomb that went off, and I'm told that the Japanese knew about this. They didn't know exactly what was going on, but they had heard about this, and this will come up again in a moment. The big question at this time is, how does the U.S. use this new weapon? And what are the future implications vis-a-vis the Soviet Union? So May 1945, Secretary of War Henry Stimson. By the way, my father got an award from Stimson, which I have at my house. Kind of interesting. I don't know what the award was about. My dad never talked about the war and what he did during the war there, but he got some kind of award. Maybe he got to figure out how to separate the uranium. Who knows? With the approval of Truman, formed the interim committee of top officials, which was Vannevar Bush, James Conant, Carl Compton, Undersecretary of the Navy, Ralph Bard, Assistant Secretary of State, blah, blah, blah. So Oppenheimer, Enrico Fermi, and A.H. Compton and Ernest Lawrence served as scientific advisors, while General Grove Marshall represented the military. This committee met on May the 31st, and then again the next day with leaders from business around the Manhattan Project. And at this 31st meeting, May 31st meeting, Lawrence suggested that a demonstration of the atomic bomb might possibly convince the Japanese to surrender. However, this was rejected out of fear that, one, the bomb might be a dud, fair enough. Two, the Japanese might put American prisoners of war in the area. By the way, this might be a dud. They hadn't really dropped the bomb out of a plane yet. They had one sitting on a pole. That's a lot different than getting one to go off at the right height off of a plane. And then thirdly, they might manage to shoot down the plane. I'm told that the Enola Gay, which we'll see in a moment, only one plane was going out at a time. They didn't want to have an armada that would look like something going on. So the Japanese sort of didn't pay much attention to this plane that went through. Excuse me for jumping around, but I think you got the point. And the shock value of the new weapon could also be lost. These reasons and others convinced the group that the bomb should be dropped without warning on a dual target, a war plant surrounded by workers' homes. On June 6th, Stimson informed President Truman that the interim committee recommended keeping the atomic bomb a secret until Japan had been bombed. The attack should take place as soon as possible and without warning. Truman and Stimson agreed that the president should stall if the Soviet Union asked about atomic weapons in the upcoming meetings to be held at Potsdam, and that it might be possible to gain concessions from the Soviet in later. You've probably all seen these. Now, it turns out that there was written opposition to the use of the A-bomb without warning by scientists at Chicago and Oak Ridge. So here's a petition was signed by 69 co-signers at Chicago and other places that signed on to this, asking that we didn't drop the bomb, we just let Japan know about it and threatened them, so to speak, with it, and maybe they would capitulate. It turns out also, I learned about this in the late 50s. Harold Swindler was in my group at Oak Ridge. Late 60s, I guess it was late 60s. Harold Swindler was in my group, and he told me about a letter that most of the scientists, all the real major scientists at Oak Ridge, had signed a similar letter and had sent it to Szilard. And here's one of those letters, two letters, and here is Harold Swindler. And here you can look through here. There's a lot of names that maybe you've seen before. One was Alvin Nielsen right here. Harold Swindler was a prominent scientist here in Oak Ridge. And I see a couple others here that, well, I can't read them, but you can go online and find these. There was also a separate letter from Oak Ridge that had even more signatures, not quite as prominent as the ones that, so E.O. Wallen was another one, very prominent scientist here. So there was a lot of opposition to dropping the bomb on Japan by the scientists. Got a question?
Yeah, was that the letter that was confiscated by General Groves?
Pardon? Oh, yeah, General Groves and was against it. He said, we built this damn thing, we're going to use it. You know, that was his attitude. We put this whole Oak Ridge together, and also Oppenheimer capitulated, and A.H. Compton. Those three were the ones that said, we're not going to tell Truman about this.
Was the letter confiscated by General Groves? This is something similar.
Yeah, General Groves called it, he said that, I may have that in this later. He said that it was a security issue to tell them about it. They should not be telling anybody about it. Keep it quiet and use it, and then that's it. And so he was what he was. That answer your question? Here's a letter. General Groves citing security issues. In fact, Eugene Bigner was chastised for even bringing them to their attention. So here's another secret letter from a whole bunch of other scientists that you can look through here and find some names that you might recognize. Well, the bottom line is we did drop them, as you know about. And the Enola Gay was the first one that's dropped a little boy. That was a uranium bomb, the only one we had. And then there was another one dropped 3 days later, the Fat Man, which is the plutonium bomb. And each one of those killed well over 100,000. Maybe they say upwards of 200,000 each, but we don't know exactly. There are books written on that. So the bottom line is, and what did it cost? The cost breakdown, these are $1945. So you should multiply maybe 10 or 8 or something times this. Oak Ridge received 1.18 billion, Hanford 0.39 billion. This is where the plutonium was bred. Materials, Los Alamos 74. That's not, they were just supporting people there basically. Research and development, government overhead, heavy water plants, and the total was almost $2 billion. Those peanuts today's, but that would have been 20 billion back then. But that's what this guy from Tennessee had to come up with. Let me say a little bit about the rest of the world, what's going on after the war, and that sort of brings up. We can start to argue and discuss a little bit about whether we should or should not have dropped the bombs. If you ask my uncle that was on the Philippines and killed 21 Japanese in hand-to-hand combat, he said, you darn well believe we should have used the bomb, because he would have been going into Japan, on a boat. But there was a lot of opposition in the war area. This is Klaus Fuchs. He transferred a lot of important spy to the Manhattan Project to Russia. And his name was Klaus Fuchs. He was a pacifist type of guy, and I think he was a Quaker. That's one of my daughters is a Quaker. And interesting enough, when I worked at K-25, one of the things, the 3 summers I worked there, I was able to read any book that classified or otherwise in the book there, and I would read everything that I get my hands on. And one of them was on separation of U-235 in the gaseous diffusion plant. And so I left the book out on the table one Friday afternoon. And I got in on Monday morning. And if I hadn't been a good softball player, I played on the fast pitch team for Carbide at the time. And they almost kicked me out on my rear end because I'd left this top secret red book on there. And I made the big mistake by saying, yeah, but Klaus Fuchs was the author of that book. The Russians know all that stuff. That was not the right answer to the question. That was a bad mistake. So there were other people involved in this. And in fact, if anybody's really interested, here's a copy of the great A-bomb robbery by Bob Considine, who was a famous author back then, or newspaper person. And he summarizes all the spying that was going on during the war. And I'll leave this here for anybody who's really interested. If you don't take it, I'll bring it back home. But I'll leave one with who's really got an interest. You know. So there's a lot of intrigue, a lot of stuff went on. Now here's the next step is the enter the H-bomb. So the H-bomb, after the war, Edward Teller and Stanley Ulam proposed the development of a hydrogen bomb. This is the fusion bomb. You take light isotopes like helium and hydrogen, and you press them together, and you get more energy out than you do, and it's lighter, materials lighter, et cetera. And so this was a super bomb that the Manhattan Project scientists, including Enrico Fermi, James Conant, Oppenheimer, greatly opposed the development of such a new weapon as a potential threat to the human species. The super bomb would be, in Conant's word, genocidal. Following the lead of those scientists, members of the Atomic Energy Commission recommended by a vote of 3-2 against developing such a fusion weapon. But President Truman ordered it anyway. Give them hell, Harry. In fact, Hal Swiner was telling me that everybody that signed that letter from Oak Ridge were really unhappy when Truman became president after Roosevelt died, because they felt they could talk to Roosevelt and he would probably listen to them. But Truman, being Truman, he would have none of that. It was, we built this thing, we're going to use it. And that was his attitude. Let's see. You can read what Fermi and Robbie, Robbie, since no limit exists to the destructiveness of this weapon, its existence and knowledge of its construction is a danger to humanity as a whole. Well, we built one, we set it off on November the 1st, 1952, and it was really scary when it went off. People that saw that, one of my good friends, Sam Hurst, is there to witness that one off. It was 1,000 times more powerful than the A-bomb. I'll show you some examples next on the next transparency. Here is a summary that I found online that shows the development of the 2 bombs that we dropped on Hiroshima and Nagasaki, and then the first hydrogen bomb, United States, 1952. United States, 15,000 kilotons. Soviet Union started building them. Look at this one, they built 50,000 kilotons in 61. And then China built one, France built one. These are all plutonium bombs here, I think, all these Pakistan, India, et cetera. But you can see the potential 1,000 times bigger than what happened at Hiroshima and Nagasaki. And we don't know what there's no more testing of these things because they know enough about this now. We really don't know what the new weapons that is existing in Soviet Union or in China. We just don't know. So this opens the floor to questions. Here's sort of what's happened in the last number of years. This is 2020, and it's still about the same 2022. This is estimated global nuclear warhead inventories. There was some negotiation that went on that draw our power down and the numbers down to equal that of the Soviet Union out in here somewhere. But the United States, Britain, France, Russia, and China are known to have conducted hydrogen weapon tests. So we know that all these countries have it, and North Korea probably does. We don't know that. 2017 they claim to have it, but anyway. So this brings up the question. We are sitting here in 2022 with Russia threatening to use nuclear weapons. I think I've heard that Putin is threatening to do this. And this would be not only would be, if a nuclear war broke out, it would be catastrophic for humankind. There'd be millions of people killed in the first few hours of such a divided war. But it would linger on because you would have all this debris up in the atmosphere. It's called nuclear winter. And I had a guy named Alan Robot from University of New Jersey, I think. And he gave a talk last year at UT and also with Friends of ORION, that went over the idea of a nuclear winter. So the nuclear winter would be such that it would block the sun out, you wouldn't have to grow plants, and society would die a slow death rather than immediate death from the bomb itself. It would be a tremendous thing. So I'll open the floor up to any questions, and I appreciate your attendance and appreciate being able to talk on this in such short time, but it's fun. It's not fun. I didn't say it's fun. It's a eye opener. I must say personally, I was 8 years old when I learned about the bomb being dropped, and everybody in Oak Ridge was running around banging pots and pans. When I found out that there was 200,000 people killed, or more than that, really, I said, this is not something, I'm glad that we won the war, or otherwise we would be war criminals. Anybody disagree with that? Raise your right hand. That's the way the world is. And if Putin does it, he's already a war criminal in my mind, but this is another story. But when I was that age, I was very much against it. And I'm still against us using it. Yeah, it's sort of a personal thing that each person has to grapple with. Should we have done it or not? And I think there's other alternatives than dropping it. I'd love to have talked about it with my dad, but we never talked.
I'll go back question for you.
Yes.
The scientists had a lot of input along various stages. Maybe not at the important times and not with Truman, but and that changes from time to time. Does anyone have Putin's ear at the moment that you know of? And what do you think of the Russian scientists? What's their attitude with what he's doing in Ukraine?
I don't know. I know a lot of the Russian scientists, and they're all really excellent people. They're just like us, most people, and there's some brave people speaking up right now in Russia. You better hit that.
Their greatest hydrogen bomb developer was Sakharov. Of course, they sent him to Siberia.
I went to Russia in '67. That was after the Bolshevik, 50 years after the Bolshevik Revolution, and I never felt safe the whole time I was there. It just seemed like a place where you don't want to step out of line.
Okay, Bob. Thank you.
Thank you, guys.